from Computer Science Department of Section C. I am explaining my topic about capacitor filter. Capacitor filter. Introduction to capacitor filters. Capacitor filters are essential components in power supply. Capacitor filters are essential components in power supply circuits. They smooth out voltage fluctuations and reduce ripple in DC outputs. Understanding their function is a key to designing efficient electronic systems. What is capacitor? A capacitor is a passive electronic component that stores electrical energy. It consists of two conductors. It consists of two conductors separated by an insulating material called as dielectric. The ability of a capacitor to store charge is quantified by its capacitance measured in farads. The ability of a capacitor to store charge is quantified in capacitance measured in farads. Purpose of capacitor filter. The primary purpose of a capacitor filter is to convert AC voltage to smoother DC voltage. It helps eliminate unwanted AC ripple that can interfere with circuit operations. Capacitor filters are commonly used in power supplies and audio applications. Type of capacitor filters. The most common types are shunt filters, series filters, and combination filters. These are the types of the capacitor filters. They are shunt filters, series filters, and combination filters. Shunt filters are connected parallel to the load, while circuit filters are placed in line. Each type has unique characteristics and applications depending on circuit needs. How capacitor filter works. Capacitor filter charge during the peak of the input signal and discharge during the trough. This charging and discharging action helps to smooth out the voltage fluctuations. The effectiveness of filter depends on the capacitance value and load resistance. The effectiveness of the filter depends on the capacitance value and load resistance. This charging and discharging actions can help to smooth out the voltage fluctuations. Capacitor filter design considerations. Key design considerations include the load resistance, ripple voltage, and capacitance value. Key design considerations include the load current, ripple voltage, and capacitance value. Higher capacitance value can reduce ripple but may increase physical size and cost. Higher capacitance value can reduce ripple but may increase physical size and cost. It is essential to balance performance with practical constraints like space and budget. Advantages of capacitor filter. Capacitor filters are relatively simple and low cost compared to other filter methods. Advantages of capacitor filters. Capacitor filters are relatively simple and low cost compared to other filtering methods. They prove decent performance of low frequency applications. Their passive nature means they require no external source to operate. Disadvantages of capacitor filter. One major disadvantage is their limit effectiveness at higher frequencies. Disadvantages of capacitor filters. One major disadvantage is their limited effectiveness at higher frequencies. Additionally, they can be bulky and heavy depending on the capacitance required. Have heavy depending on the capacitance required. They may also experience voltage leakage and degradation over time. Applications of capacitor filter. Capacitor filters are widely used in power supply AC circuits for electronic devices. They are also utilized in audio equipment to improve sound quality by reducing noise. Other applications include smoothing and voltage in radio frequency circuits and signal processing. Other applications include smoothing voltage in radio frequency circuits and smoothing processing. Capacitor selection criteria. Selecting the right capacitor involves considering capacitor, voltage rating, and type. The dielectric material can affect performance and reliability. Choosing a capacitor with appropriate ESR. ESR means equivalent series resistor. Choosing a capacitor with appropriate ESR is crucial for efficiency. Performance matrix. Key performance metrics include ripple voltage, load regulation, and response time. Ripple voltage is the AC component that remains after filtering and should be minimized. Load regulation measures how well the filter maintains a constant output voltage under varying loads. Capacitor life and reliability. The lifespan of capacitor can be affected by temperature, voltage, and frequency of use. High High quality capacitors are designed to withstand environmental stresses to ensure reliability. Regular testing and monitoring can help prevent capacitor failures in critical applications. Future of capacitor filters. Innovations in materials and design are leading to the more efficient capacitor filters. The integration of advanced electronics is allowed for smarter filtering solutions. Future developments may include hybrid systems that combine capacitors with other technologies. Conclusion. Capacitor filters play a vital role in the performance of electric circuits. Understanding their design and applications can enhance system reliability and efficiency. Continued advancements in capacitor technology will shape the future of filtering solutions. Feel free to adjust any content based on specific needs or preferences. Thank you.